Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. So the objective is to solve this inequality up here. And the teacher wants him to write, or her to write out the steps as if they were doing a proof. Now, you might have thought geometry is where you have to do proofs, and that's true, but there is such a thing as algebraic proofs, although you don't see them very often. But they're two-column proofs. This is called a two-column proof. You can imagine two columns here. Oops, got to get this straightened out. 1 second. So you can imagine two columns here, I think, without too much confusion. Let me just clean this up. Okay, so here are the columns. And there are different reasons that you can use, just like in geometry. So here we have our choices are multiplication or division property, which is pretty straightforward, I think. It's distributive property, which I assume you know. Distributive property is A times B plus C equals AB plus AC. So that's distributive. I'm sorry for my handwriting. I always have trouble controlling the stylus on this platform. I'm not sure. That's supposed to be, say, distributive property. And maybe if I just write a little slower, but then you'll be bored while I'm writing. Anyway, that's the distributive property. So we only have three choices here, so it shouldn't be too hard to pick out which is the correct choice. So here's our original inequality, and now you can see what happened was the 23 was subtracted from both sides. Should have been subtracted, and this should not be a 32. So there must be a mistake here in the sign. This must have been a negative 23. So I'm just going to fix that, turn that into a negative 23, because that's the only way you're going to get negative 32. You take negative, oh, wait a minute, I'm wrong there. Wasn't paying attention, sorry. So you subtract, no, that's right. That must have been a negative. So that's a mistake. Because when you get rid of the 23, you're adding 23 to both sides. So negative 56 plus 23 is going to give you negative. It's going to give you negative 33. My goodness gracious, this thing is filled with mistakes. Yeah, so you add 23 to both sides. So obviously we're adding or subtracting. We're actually adding here. And so this is our reason for the step, is the addition property. I can certainly see why the student got confused by all this nonsense. So when you add 23, you're supposed to get negative 33 here on the right. And the next step, he's moved, the 3x is being subtracted. You subtract 3x from both sides, and you do get negative x on the left-hand side. Let me continue with the negative 33 here. So once again, this is multiplication. I'm sorry, this is addition or subtraction. Addition or subtraction. That's the first one here. Because we've subtracted 3x from both sides. Okay. Now we're subtracting -1 from both sides. And I can see that this is absolutely wrong. First of all, this is a 33 here. And I can see what's happening. They're actually multiplying by a -1. Boy, this thing is a mess. So we're multiplying by -1 here. And when you multiply an inequality by a negative, you change the direction of the inequality. So this becomes x is greater than or equal to positive 33. And I'm assuming this is multiplication. Well, we're not really, on this step, we're not really using a property. There's no property. We're just multiplying both sides by -1. The property is applied to this step, this very last step here. So again, not very good in terms of how this question was set up. So I can understand why the student in this case was confused and had a lot of trouble with this. So even though it's a simple problem, I'm glad we took the time to go through it so that you're not being driven crazy by it. And that's basically it. I don't think we need this last entry at all. And that should be it for this one. Yeah, so just be aware that when you take algebra, sometimes when you're in Algebra 2, they start teaching you these properties and they ask you to do algebraic proofs. Typically, that doesn't last very long, and most people never see this again. You might see this again like at the college level. All right, that's it. I'll see you guys next time. Bye-bye.